Hello, welcome back to Educator.com and welcome back to Biochemistry. So today we're going to continue our discussion of enzymes by talking about enzyme inhibition. Enzyme inhibition is exactly what you think it is. We have an enzyme that does something. We want to either completely stop it from doing something or we want to slow it down a little bit. There is also something called positive inhibition, where you want to actually cause an enzyme to do what it does a little bit better, a little bit faster. But for the most part, we're going to be talking about negative inhibition. So again, inhibition, exactly what you think it means. So let's get started and see what we can do. Okay, so enzyme inhibitors, excuse me. So enzyme inhibitors are molecules that interfere with enzyme action or enzyme activity. Now, it is no surprise that a large percentage of current pharmaceuticals on the market, a large percentage of pharmaceuticals are in fact enzyme inhibitors. Pharmaceuticals are enzyme inhibitors, and that is a huge, huge, huge area of pharmaceutical research. Enzyme inhibitors. We discover some metabolic pathway. We discover something in that pathway, some enzyme where we know how to control it. We control it. We mess with it. That's what we do. Okay, so now there are two broad classes of enzyme inhibitors. Classes of inhibitors. Excuse me. We have something called reversible, and exactly what you think, irreversible. Now let's go ahead and deal with the reversible first. I'm going to go ahead and do this in blue. So, reversible. Now the reversible comes in three varieties. Something called a competitive inhibitor. It's exactly what you think it is, but we'll give a definition in just a minute. An uncompetitive inhibitor, and a mixed inhibitor. Mixed being combination of competitive and uncompetitive. Okay, so let's go ahead and deal with these one at a time. So the first thing we're going to deal with is competitive inhibition. It's the most intuitive one, the one that that is most easily understood. So competitive inhibition. So competitive inhibition is exactly what you think it is, exactly what it sounds like. It's where the inhibitor, which again is a molecule, where the inhibitor molecule, it competes directly. It competes directly against, I'll say with actually instead of against, doesn't matter. It's competing with the normal substrate for binding to the active site. It competes directly with the normal substrate for the active site. So they both want to be in the active site, substrate, competitor. If substrate makes it, the enzyme does what it does. If the competitor makes it to the active site before the substrate does, that's it. It blocks off entrance to the active site for the normal substrate. Excuse me. So pictorially it looks something like this. So let's say you have some enzyme, it looks something like this. Okay. Excuse me. So let's say our normal substrate looks like that. So when the enzyme and the substrate come together, I'll put S here, and I'll put E for enzyme, we end up with our enzyme substrate complex. Well, the inhibitor, let's say it looks something like that. Now, if the enzyme binds to the inhibitor, you end up with something called the enzyme. So this is the enzyme substrate complex. You end up with something called an enzyme inhibitor complex. And now because this inhibitor is occupying the actual active site of the enzyme, the substrate itself can't come in. So it's blocked. The enzyme is inhibited. That's it. Whatever metabolic pathway happens to be involved, it stops at that pathway. It doesn't do what it's supposed to do. This is competitive inhibition, competition for the active site. In terms of the E's and S's that we were talking about before, it looks something like this. You have the enzyme plus you have the substrate. They can form something called the enzyme substrate complex that can go on to form enzyme plus product. Now the enzyme, instead of binding to the substrate, can also bind to the inhibitor, forming the enzyme inhibitor complex. So this is what it looks like in terms of E's and S's and things like that. Now, let's go ahead, and for this, I'm going to introduce something called K sub I. I just want you to be aware of it. This, write it again, this K sub I is not a rate constant. This is an equilibrium constant. So here, this K sub I is equal to the concentration of E sub I over the concentration of E times the concentration of I. That is this reaction right here, the equilibrium. It is the dissociation reaction for the enzyme inhibitor complex, okay? Products over reactants. These are the reactants. This is the product. This K sub I, it's the equilibrium constant for the formation of enzyme inhibitor complex, or it's the dissociation constant, if you will, for this complex that way, depending on which direction you want to take it. It's just an equilibrium complex, okay? It will show up a little bit later, but we're not really going to be doing too much with it. It's just something that you should know.